So what's the difference between AWS IoT and Azure IoT? Okay. All right, so what's common about Azure and AWS is that they both support digital threading. So let's talk about what digital threading is first. So the digital thread approach to digital transformation is we want to create digital threads on the plant floor. I want to create objects out on the edge. For the purpose of this, we're just going to talk about sensor data. We'll also talk about what they miss. So I may create two digital threads, one that's a triangle and one that is a square. Those are models, okay? The digital thread idea is that we get the sensor data, that model, we get it from the raw sensor on the plant floor. We get it from the raw sensor on the plant floor into some edge device as quickly as we can and model it. Okay, so I've created a triangle for this one and I've created a square for that one. And for every type of sensor of this type, it's going to go into a square model. Then what we do is we quickly try to get that into a storage location in the model that we created on the edge. And then what we do is we put an analysis layer on top of our data lake. So storage is our data lake. We create an analysis layer that can also process those two objects, okay? And then we create visualizations that work for those plus star, okay? And then the human being interacts with those layers, okay? So that is your digital thread approach, which when you hear us talk about the unified namespace and how to successfully leverage digital transformation to help manufacturers do more with less, our focus is to unlock potential on the plant floor back down here. That's the key. That's a key functionality, key value that is missing from the digital thread approach. Okay, digital threading is important. This is actually an important functionality, but it is not the backbone of your IIoT infrastructure. Okay, but understand that this is the digital thread approach, and both AWS and Azure do this. One of them is really good at doing digital threading and plugging into a unified namespace, and one of them is not, although both of them are capable of doing it depending upon which technology you select, okay? All right, so let's talk about Azure. So what they do is they all do some type of edge, IoT edge. They have some type of IoT core, and then they have some type of IoT insight or visualization layer. Both solutions do. Okay, we're going to talk about Azure first. Out on the edge, Azure, they use these marketing terms: things, insights, and actions. So the things are all the stuff out on the edge. The insights are processing of the data, and then the actions are the way human beings interact with that layer. Out on the edge, they use a product called Azure IoT Edge. Azure IoT Edge does lots of things, including pre-processing of data, creating these models, these little digital threads for you out on Azure IoT Edge. And generally what they do is Microsoft created a broker pub/sub technology called AMQP. Okay, so that's one of the broker technologies we talk about. That was actually developed by Microsoft, and it is used all throughout the Azure infrastructure. Okay, AMQP is. Azure supports MQTT, but only supports MQTT 3.1.1. So if you look at them natively, if I want to go from Azure IoT Edge into the Azure IoT Hub, take my things and go up into the hub using MQTT, I'm going to do that over 3.1.1, so flat vanilla MQTT. Or I can use their SDK to create my own custom payload if I wanted to. I could do that, okay? The Azure IoT Hub layer is where all the insights happen. It's where their data lake is. It's where all of their pre-packaged analysis layers are. This is when you've gotten to the cloud. This is on your plant floor. This is you in the cloud. Azure IoT Hub has this store analyze layer, okay? The analysis layer on top of the store for our digital thread. And then they want you to use their tools, right? So Power BI, Power Apps, is the actions layer for Azure. So Power BI, Power Apps Plus, you can take the IoT hub data, you can take that data and you can get it to other applications. It is open. It favors, there's two fundamental flaws in my opinion with the way Azure approaches this. Number one, Microsoft is a Rockwell partner and they are a OPC Foundation partner. So the modeling engine that they use, or that they at least steer you towards out of the box, is using OPC UA for the model engine starting out on the edge. And we're going to show a ton of metrics as to why not to do that, okay? OPC has a place out here on the edge for process control primarily, but it really shouldn't be, those models should not be part of your IoT infrastructure. So number one, they're partners with Rockwell, Microsoft is, and number two, they're partners with the OPC Foundation. So by default, they steer towards the OPC UA model, and they steer towards AMQP for their broker technology, number two. And number three, they don't support SparkPlug-B, okay? So number three, there is no SparkPlug support in MQTT from Microsoft, okay? Although you could create it with the SDK. But out of the box, there isn't any SparkPlug support. So we do work with Azure IoT. I like the Azure IoT solution. If it gets spec'd in, that is, the client is already settled, that Azure's already been selected, they've already invested too much money, we got to make do, then what we're almost certainly going to do is out on the edge, we're not going to use the Azure IoT Edge solutions for anything other than like high-speed telemetry data and maybe some Lambda functions. But we're going to put an IIoT gateway out on the edge to convert to the Azure connector, okay? So that we can get it into SparkPlug-B. So we'll get it to SparkPlug-B here. We'll stream it over the native Azure connector to the Azure IoT Hub. Generally, we do this with Ignition. Cirrus Link wrote an Azure connector for Ignition. Generally, we do this in Ignition. And then we've got it for SparkPlug-B to go out into our infrastructure, okay? Most of my issues with Microsoft's solution are Microsoft doesn't encourage you to do what's best. They encourage you to do what their partners are offering. That's why they use the OPC UA model. That's why they're using the OPC models for the data when they're packaging the payloads. It doesn't make a whole lot of sense that they haven't adopted SparkPlug-B yet. It really makes no sense other than it was a strategic decision because of the relationship they have with the OPC Foundation and the relationship they have with Rockwell. That is really the reason, in my opinion, they have not adopted that technology. Okay, so let's talk about AWS. So, but let me say this. If somebody asks me on a scale of 1 to 5, how do you rate Azure's IoT solution? I'm going to give it a 3, right? So I'm going to give it, it's not a bad solution. It's got a lot of great features. You can build a very powerful IoT infrastructure using MQTT or AMQP, but you're going to have a bunch of add-ons to close your gaps. A lot more add-ons to close data gaps and capability gaps using Azure than you would using AWS. So AWS calls their edge component AWS IoT Greengrass, which Greengrass is really where, Greengrass for us primarily is where we run Lambda functions. That is, we do pre-processing of data either to filter data or to transform it, okay? So the AWS IoT Greengrass on the edge, and then they also have AWS IoT Sitewise, which has both an edge component and a cloud component. So you've got the AWS IoT Sitewise connector, which basically allows you to connect equipment to be managed by the cloud Sitewise product by AWS. In the middle layer, so in the store analyze layer, you've got AWS IoT Sitewise, which is really your industrial solution. That's really the solution you use to manage industrial equipment. Has a whole bunch of other features, but I'm trying to keep it, we're going to do a much more in-depth evaluation. And then you have AWS IoT Core, which is really the suite of applications that is comparable to the Azure IoT Hub. For the analysis visualization layer, so once you get above your data lake, so you've got Kinesis for all your optimization. There's a whole bunch of applications in here, by the way. I'm only highlighting your layers. Right. You have an analysis layer, and then the visualization layer for AWS proper is QuickSight and Athena. Those are the two tools that they primarily market as AWS IoT. But the big advantage of Amazon Web Services is that AWS has Spark-Plug-B support right out of the box. So we use AWS, we do IoT Greengrass all the time, right alongside of Ignition. There's an Ignition connector directly to Greengrass. Sometimes we pipe, Edge Greengrass into Ignition for unified namespace, and then we come up. There are times where we go Greengrass to Ignition to add additional context, come back to Greengrass up into the core. You have way more flexibility with the architecture, and with flexibility comes the ability to close data gaps and capability gaps. So there is Spark-Plug-B support out of the box for Sitewise called, I think it's called the Sitewise Spark-Plug Bridge or whatever. But there's native Spark-Plug-B support. So you can use MQTT 3.1.1, which Azure supports. You can use Spark-Plug-B. You can create custom payloads. Azure, you can do 3.1.1. You can do custom payloads with the SDK. And you could write a Spark-Plug-B connector, but nobody has done that as far as I can tell. And it certainly isn't sponsored by Microsoft because they want to steer you away from Spark-Plug. There's a reason. I mean, there's strategic reasons that they're going in the opposite direction. Okay, but here's the beauty of AWS out of the box. Here's something you can do with AWS you can't do with Azure, and that is I can have a unified namespace out here, out on the edge, okay, that AWS is connected to along with my edge components. So I have AWS IoT Sitewise and Greengrass can be connected to my UNS out at my plant level, which when I transmit up to my unified namespace at my enterprise level, so everything above this line is your enterprise, I can connect AWS IoT Sitewise and IoT Core to my unified namespace at the enterprise level, and I can create visualizations. I can, in addition to QuickSight and Athena, I can create context visualizations using my IoT platform up here. Azure is an open solution. I would never describe Azure's IoT as not being open architecture. It is edge driven. It is mostly report by exception, but I would definitely argue it is not lightweight. And it isn't as open architecture as AWS's solutions are. So, in a nutshell, Azure and AWS their models are very, very similar, right? They architect very similarly. They try to use edge connectors for digital threads, but AWS has the added advantage of being able to, if my IoT infrastructure, if I'm going to create an IoT infrastructure, and this much of it is digital thread, and this much of it is UNS, and it's actually probably much more than that. It's UNS, which is the edge-driven, report by exception, lightweight, and open architecture. So digital thread is going to get me, maybe a third of my value. But the unified namespace, an open architecture unified namespace that's built on a technology stack, is going to give me the other 2/3 of my value. And the way that we break that out is digital thread is really, really good at capturing high value opportunities. AWS and Azure capture high value opportunities at the same level, right? I'm going to be able to capture the high value ROI the same with Azure and AWS. The problem is that when you use an Azure infrastructure, you are almost certainly going to price yourself out of the mid-level and low-level opportunities much faster than AWS. And because AWS natively integrates, because of the technology it supports, because AWS natively integrates with Spark-Plug-B MQTT infrastructures, it is more open architecture than Azure is. You can capture more value, more mid-level, low-level value with AWS by being able to leverage other parts of the ecosystem much more effectively, okay? And so that's the reason when we're architecting a solution, when we start building out the unified namespace architecture, the customer almost certainly has a digital thread implementation, in place, or they've at least started, because Microsoft and Amazon are selling really, really hard to large enterprise companies, and they're selling digital thread technology. right? That's what they're selling. They're selling a digital thread stack. They're not selling a technology-driven approach. Although, we deal with Michael Brown at AWS. He's a member of our community. Michael Brown, through my conversations with him and his posts within the Discord server and on LinkedIn, he is a huge proponent of AWS being a node in your industrial ecosystem. It's what he believes, it's the way he architects, it's what he sells, and by virtue, that's obviously that is a function of AWS's approach. That is not Azure's approach. Microsoft's approach isn't Microsoft's going to be a node in your ecosystem. What it is Microsoft and Microsoft partners are going to be your ecosystem. That's their approach. And so what they're going to tell you is everything's going to be great on the, if you're using Azure IoT and you're using Microsoft partners and by extension Rockwell partners, we're going to be able to solve all your problems. The issue is that they're not best in class in every layer of the stack. All those people, all those partners, you're going to pay more, a lot more, significantly more. And you may not be directly vendor locked with a solution-centric approach, but you are going to be vendor locked through Microsoft and Microsoft's partners. That is their approach. Let's solve the customer's problem. And it's not let's solve the customer's problem with Amazon's solutions. It's let's solve the customer's problem.
So you gave Azure a 3 out of 5. What would you give AWS?
I mean, in the right infrastructure, in the right architecture, AWS is a 5 out of 5. That infrastructure would be that I've got an IIoT platform out on the edge, okay, one that meets our minimum technical requirements. We've got one at the site layer or at the enterprise layer, and then we have designed an architecture using AWS's tools to get the context that's created at the core SiteWise layer and at the QuickSight Athena layer and that analysis component in the middle. We have a mechanism to get that context back down to the plant floor through the unified namespace so we can unlock that potential on the plant floor through engineers, maintenance, through operators. That is very, very difficult to do on this side, by the way. I mean, you have to create additional point-to-point connections in order to achieve that returning of context back to the plant floor. There is no mechanism currently in Microsoft's strategy. The Azure strategy is to take data from the edge, move it in one direction, and then sort of create solutions, store it, analyze it, visualize it, and it's through the visualization up at this layer that we're supposed to be unlocking potential on the plant floor. We know that that's not what you need to do is be able to, as we add new raw data and new context as we move up the stack, we have to have a mechanism to distribute that back to all the layers in the stack. It's much more difficult to happen on this side. It has to be it's built into the architecture here. It's just baked in. Over there, it has to be a conscious decision with additional point-to-point connectors. Go ahead.
Last question. Let's say I'm a manufacturer and I want to get the right architecture. What's my next step?
We talk about this all the time, and we had a meeting today with our team about why do we approach problems the way that we approach them? What's the reason that we're committed to the approach that we take? And that is, over the last 7 years, we have discovered that helping organizations successfully digitally transform from an industry 3.0 company where I just have automation and tons of data that I'm not doing anything with, to an industry 4.0 company where I've got an automated business that's fully integrated and I'm operating on making decisions in real time from digital data and information. I mean, just, two completely different worlds. There is a playbook. I don't want to use the term playbook. Thank you, Jason Koop, by the way, for the playbook term. It's all that's been stuck in my head lately. But there is a process, we call it the steps to digital transformation, that is tried and true. And that first step, there are really 3 core rules to digital transformation. Number 1, it's a strategy. It's not a project. Digital transformation is a strategy. Number 2, it's about changing the way you do business. And number 3, it starts with admitting you have a problem. All right. So step 1 in digital transformation is you got to admit you have a problem. We're not capable of unlocking potential on the plant floor because we're in a way that is scalable for our business. We can capture value. By the way, Anybody can capture value using digital thread on high value targets if you're willing to invest, a couple $1 million. If you've got a couple $1 million to invest into an IoT strategy, you can go ahead and go with one of these digital thread architectures to start. Everyone does. They learn very, very quickly there are gaps. You have data gaps and capability gaps by using the digital thread approach. And so then they start looking for how to close those gaps. Because what ends up happening is, you'll spend several $1 million getting this implemented. You'll capture a couple of high value targets. It'll pay for itself. You don't lose money on it. But then all of a sudden you realize people on the plant floor aren't using it. And the reason they're not using it is because it's not solving their problems. And that's what we refer to as unlocking potential on the plant floor. And the way you solve their problems is by enabling them to solve the problems for themselves. Let them use data and information to start solving their own problems on the plant floor. And when they come up with a really great idea, you have to have a mechanism to scale it across the whole business. You can't do that here. That is not part of this process. Okay. So number one, you got to admit you have a problem. If you would recognize you want to digitally transform and you want to use the digital thread architecture, which by the way, digital threading is going to be part of your IIoT solution, but it simply will not be the foundation upon which your ecosystem is built upon. That has to be a edge-driven, report by exception, lightweight, open architecture, protocol, and standard, which in our case, we use MQTT and Spark-Plug-B. All right, so step one is admitting you have a problem. Step two is you need to get evaluated. Step two is inventorying the business. What's the strategy of the business? What do you have today? Where do you want to go? Step three is inventorying the intelligence, all the smart things that you have in your business. And step four is putting that all together to come up with a plan to do a proof of concept, which gives you maybe this, but definitely this piece. You want this to be part of your proof of concept, the core of your proof of concept. So you have to have three things. You got to have the right partners, you got to pick the right technology, and you got to start with the right strategy. So to answer your question, if you want to know more about this, if you want to start the process, that assessment process. So I've admitted I've got a problem, and now what I want to do is inventory the business, I want to inventory the intelligence, and come up with my architecture and plan, my strategy, my architecture, and my plan, which starts with the proof of concept for implementing this. There's going to be a form down below. There's a link to a form down below that you can fill out, and we can steer you in the right direction. Either get you in contact with the right partner to do this for you. Okay.